Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to build a basic VOIP system inside of Godot. So we're going to go through the process of talking about how to capture your microphone. We're going to talk about how to take that data and compress it in a decent way. Basically, we're going to cut the data amount in about half. We're going to talk about how to create a basic multiplayer system so that way we can test our VOIP system. And finally, we're going to host it out on DigitalOcean, and we're going to do a small test to make it work. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing we need to do is we need to actually set up our node structure. Now, I am stealing a little bit of this node structure from this Reddit post right here, which is by Pass the Coding. So thank you, Pass the Coding, for kind of showing off this little node setup here. It's actually a really good little setup to get started with recording your microphone and some of the VOIP stuff. Now, when we want to set up our nodes, all we have to do is first start with a base node. And in my case, I'm going to add in a node like so. And then I'm going to right click, add in a child node, and I'm going to add in a input of some description, which in this case is going to be an audio stream player. Now, you need to have some way for you to bring your voice, record your voice and to send it across the wire, right? That's basically the basis of VoIP. But in Godot, recording your voice is a little bit different. So first you need an audio stream player, and we're going to call that input. Then we're going to actually create an audio bus. So we'll go to audio right here, and we'll basically come in here, hit add bus, and then we're going to add a second bus. We're going to call this the mute bus, and we're going to call this record, like that. Now with record, I'm going to go to add effect, and this is where you're going to add any effects that you want to your guys' voice. So for instance, if you want to equalize it, you want to add a delay, you want to amplify it, things like that. In my case, I'm only going to put really just one. And of course, you can put whichever ones you guys would like, but I'm going to put the capture in it. And what that's going to do is it's going to tell Godot that we're going to capture your microphone right here. Then we're going to click on master and change it to mute bus. And then we're going to click the M button right here on the mute bus. Now you might be asking, okay, why am I doing that? Well, the record bus records your voice, right? It captures that voice. That's why we have this little capture here. But if you talk into the capture bus, what's going to happen is it's going to replay your voice into your headphones. So you need to mute it somehow. And you can't just click mute, because if you click mute, what's going to happen is it's going to mute your microphone input. So we're going to route your record bus through your mute bus, and that's going to basically allow you to mute it without losing your recording, if that makes sense. Now, once we have this little bit of a setup, we're basically done with this tab. So we can click audio to close it. We'll click on our input, and then we'll go to master and change it to record. And once we have this, we can go up to our project settings, and then we can turn on advanced. And then we can type audio, and you'll see that we have an audio section right here. If we go to driver and we click on enable input, that's going to allow us to input our voice into our project. And for mix rate, it depends on what the person's microphone is. In my case, I use 4800, so I will put 4800. And then we'll hit save and restart. Now Godot's going to reboot and get things going, and then we'll go ahead and re-snap this back. And I didn't save my settings, so of course I lost my input. So I'll go with other node. I'll type node like that. We'll right click, add a child node, and put in an audio stream player like so. And I'll rename this to input once again. That was my fault. Now I'm going to rename this to audio manager, and I'm going to go ahead and hit Control S, and I will hit save. Now I'm going to right click this guy, attach a script, and we're going to call it audiomanager.gd. That's fine. Now, first things first, we need to basically set up our audio, and we can't do that on Ready because since this is a VoIP system, we need to be able to set up our audio and set our multiplayer authority and do things like that. So I will go ahead and do that first. So we'll come down here, type func setup audio like so, and I'm going to pass it an ID. Now, since this is a multiplayer tutorial, we need to actually set up our multiplayer authority. So we'll say set underscore multiplayer authority. We'll pass in our ID. And now we'll need to actually start recording our voice, but we only want that to happen when it's the person that is the multiplayer authority, right? We only want if you're the actual player, right? If you're the person that's controlling this audio controller, you only want this person to record, right? You don't want to record yourself and then play it over top of somebody else. So we'll say if is multiplayer authority, then we'll go ahead and set up our record. So in our case, we'll take our input and we'll set it up. Now we're going to want to make our input a global variable for this class, because if we want to reuse it somewhere else, we can. So what we'll do is we'll come up here, we'll say var input is of type audio stream player, and we'll make that equal to $input, like so. And we'll need to hit @onReady, because we're going to want to do this on ready, so that way it automatically sets up our object. Now you could do that down here, of course, if you want to. Now we need to set up our ability to record. So we'll say input.stream is equal to audio stream microphone.new. And what that will do is it'll actually set up our microphone. What we're doing is we're saying if we're the authority of this, so if we're local, then start setting up our microphone. Then we can say input.play. So that's going to play and record our audio. And then we need to set up some kind of index. So I'm going to come up here and say var index, and I'm going to make that a type integer. And then I'll come down here and I'll type index is equal to audio server dot get bus index. And we'll make that into the record index, like so. And then we need to have what's called an effect. An effect is basically like an audio effect. So it's basically like a way to capture our audio, if that makes sense. So we'll come up here and say var effect, and we'll make that an audio capture. And you can notice that if I type var audio EFF, you can see that we have a bunch of different effects. So think of it kind of like, if you remember down here, we have these effects. That's what this is. It's an audio effect capture. It's basically this guy right here. So that's more or less what it's doing. Now we want to set our effect equal to this little capture effect. So we'll say audio server dot get bus effect, and we'll pass it our index, and we'll pass in the first effect. So that's going to be this guy right here. They go by index. So if I have a limiter and I want to access that limiter, I would say 1. So it's 0, 1, right? So it's whichever one that this guy is. In this case, since it's the first one here, it's going to be 0, but that's just something to keep in mind. So you want to make sure that that's a common troubleshooting issue that you'll run into if you don't play close attention, that whichever one this is, it starts with 0, and it's whichever index this guy is. And now we need to set up our playback, right? So when you talk, you need to be able to play it somewhere. So in our case, I'm going to come up here and say var playback, and I'm going to make that equal to an audio stream generator playback. And that's basically going to allow us to play back that audio. Because remember, when you're talking, that gets translated into information, and then it needs to play somewhere. So we'll say playback is equal to, and we're going to want to make this flexible, right? Because we don't know exactly what type of, because I don't know what type of audio you need. You know, it could be that you just want a very basic non-positional audio system, or it could be that you want a 3D positional audio system, right? So we need to make this a bit flexible. So what I'm going to do is I'm going to pass in a node path to a object. So I'll come up here and say at export var output path. We'll make that into a node path like that. And then we'll say get node output path dot get underscore stream underscore playback, like that. And what that will do is it will actually grab the node that we want to play with. So remember, this audio manager is going to be used inside of the scene, and it's going to relate to something outside of this audio manager scene, which is why I'm doing a node path. That way I can reference stuff outside of my scene without needing to do any fancy get tree or anything like that. I can just go and grab it by using this little node path. Now, at this point, we need to basically process our microphone. So what we'll do is we'll come into our process node here, and we'll say if is multiplayer authority : and then we can process our microphone. Now I'm going to pull this out as a function because it's going to make it a little bit more flexible, a little bit more organized, and a little bit easier to work with. So we'll say process mic like that. We'll come down here and say func process mic, and we'll go ahead and process our microphone. Now, what this is going to do is it's basically going to pull back our data as a vector2 array, and then we're basically going to convert that to a float array, and that's going to help compress our data. Something that's important is reducing the amount of data that gets sent over the wire. So what we want to do is a vector2 array is a combination of two numbers, and it's basically double the size of what a packed float array would be, right? Because a vector2 array is two numbers versus a float array, which would be a one number. So that's kind of the idea. So what we'll do is we'll say var stereo data as a packed vector2 array is equal to effect dot get buffer. Now, what get buffer does is it pulls back the buffer of your audio processing engine, right? So think of it kind of like this. When you say get buffer, you're saying, hey, read what has been said into the microphone. And we have frames. And basically frames is how much data we're going to try to pull. Now, you could basically throw a number in here if you want to. You could type like 512 or 256 or something like that. But typically it's best just to say effect dot get frames available. And that will pull back all of the available frames that are currently available. And now all we have to do is say if stereo data dot size is greater than 0, then we can actually process our data. So when we get our buffer, if there's nothing in there, like the microphone's not connected or something like that, then we don't need to process that data. So we can basically just pass right by it, right? But if we do have data, then we want to initialize a packed float array. And I'm going to make that a 32 because we're really not going to go higher than a few decimal places here or there. So we don't need a 64-bit array. We can get away with a 32-bit array. So then we need to resize our packed array because basically if our packed array is not the correct size, you're going to get into a bunch of errors. So what we'll do is we'll say data.resize. We're going to resize it to the same size as our stereo data. And then we can come in here and say var max amplitude, and we're going to make that equal to a 0 like that. And I'll explain what that is in a minute. And now we can basically loop through our data. So we'll say for I in range stereo data dot size like that, var value is equal to parentheses stereo data bracket I dot x plus stereo data bracket I dot y. And I did O instead. There we go. Divided by 2. Now, what this is doing, this section here is basically saying, I'm going to get the average of these two values. So if for some reason you have directional sound, I'm going to get the average of the two, and then I'm going to divide it by 2 so that it gets that average, right? So you add them together, divide, grabs the average, and that way we're only passing over the average value. Now, odds are extremely likely we could just pass in the X value and it would be fine. But just in case, for whatever reason, if they have like some funky stereo volume data or something weird like that, we're just going to basically average it out and then pass it along. And now we're going to check our max amplitude. Now, remember, we have max amplitude here. The purpose of this is just to see if that max value is loud enough for us to be able to send that data over. So we'll come down here and say max amplitude is equal to max bracket value, comma, max amplitude. And then we'll say data I is equal to our value. Now we can check if our max value amplitude is less than our input threshold. Now, we don't actually have an input threshold, so let's add that in. So we'll say var input threshold, and we'll make that equal to 0.005 or so. So what this is going to do, and I'll put a 0 in front of this just because I like having the 0 there. So what this is going to do is basically say if our person, whoever they are, is talking loud enough, then we will be able to send that data across. Now, in this case, I'm going to go ahead and return, because basically if their maximum volume is higher than what our input threshold is, then we're good to go. If not, then we're going to go ahead and return and not pass that data across. And basically, that's our entire mic processing. And if you're curious, the reason why we're doing this is because if you're just sitting in pure silence, then this will not pass that data across, because you don't want to record data that's not there. It's just going to add additional latency and additional garbage into your system. So we'll just do it like that. Now, since we don't have the ability to actually RPC our stuff across, what we'll do is we'll print the data. So I'll print data like that. And now, hopefully, in theory, if we set up a small scene to test this, we can go to scene, new scene. We'll add in a 2D scene. We'll go ahead and add in our audio manager like so. Control S, we'll call this test scene like that. And then we'll right click our node, attach a script, and let's just call it test scene manager. Now what I'm going to do is come in here and basically instance in our audio. So we'll say at export var audio manager : packed scene. And then we'll say on ready, let's instance our audio manager. So var s is equal to audio manager dot instantiate like that. And then we'll just say s dot setup, and I believe it was setup audio. If I come up here, we have setup audio. So we'll copy that. We'll bring this in here like this, and we'll pass in the ID of 1 because we don't really actually have anything set up yet. So hopefully this should work, but we'll see. So we'll say setup audio 1, and we'll say add child S. And in theory, that might work. So we'll go ahead and hit play. And we'll save it. We'll click on this guy. Audio manager's empty, so I'll drag this guy in, and then we will hit play. And we have a crash. Playback.get node output path get stream playback. And that's because our output path is null. So normally what we would do is we'd have to assign that as our node path. So that means that this object needs to kind of exist. So what I'm going to do is right click, add a child node. I'm going to add in a node 2D, and I'm going to call this character. And I'm actually going to take this bit of code here. I'm going to copy it, and I'm going to drag our audio manager scene underneath our character scene. I'm going to right click, add a child node, and I'm going to bring in an audio stream player 2D. I'm going to click on my audio manager, and for my output path, I'm going to assign it to my audio stream player, and then I'm going to drag my character right here. So now I have a character.tscn. I'm going to get rid of that character, and then right here where I'm doing my audio manager.instance, instead of doing my audio manager, I'm just going to say character like that. I'm going to change this to character, and then I'll say character dot get node s dot get node, and I'm going to pass in my actual audio manager here. So I'll grab this guy, and I will say quote audio manager dot setup audio 1, and in theory that should work. So I'll hit play, and it says cannot instantiate on a null value. That makes sense because this got reset. So we'll redrag our character in here like so, and then we'll hit play. And so now we have a issue where it says cannot get null value on get frames available. So that means that our effect for some reason is null. So let's see. My guess is it's because is multiplayer authority. Let's check our audio real quick. That should have worked. So we'll refresh real quick. All right. So it's not running this, but let's refresh it one more time, throw a breakpoint up here. So it's attempting to set the ID to 1, and then it doesn't let it do that. So what I'm wondering is, do I need to say multiplayer.get unique ID? And then let's see if that gives us anything good. No, because my guess is that since we're not doing multiplayer just yet, it's bricking out here. So what I'm going to do is comment that out for now, and we're going to hit Control S, and let's attempt that one more time. And now it's mad because input.stream is null, because my guess is input is null. It is, because our ready hasn't ran yet. So let's go input is equal to $input, like so, just to kind of mitigate that issue. There we go. And now let's refresh. And we still have an error here. Playback can only happen when the node is inside of a tree. Call play before getting playback. So let's see. First things first, setup audio. Playback can only happen when it is a part of a scene. That's because setup audio is being ran before add child. So we'll go ahead and Control X, paste that like that, and that should fix that issue. And now you should be able to hear me a second time. So the reason why you can hear me is because we must have the wrong bus set here. So let's take a look at our audio manager. And I'm going to shut this guy off so that way it's not killing us in terms of hearing me echo. So if we hit input and we go, and you can see our bus right here is set to master. So let's set that to record. And then let's go ahead and try that one more time. Now we're going to hit play, and you'll hear that you can't hear me anymore, but you will see that we have a lot of data coming through here, which is perfect. That's exactly what we want. That's the voice representation of us talking as our audio data, so that way we can transfer that data over. And now we have to take that data and actually transfer it across the wire, and then we can pass it into our buffer to be processed. So I'm going to cancel this, and we're going to go ahead and build out the processing side of this data. Now, I think the simplest way is going to be to make this run local first, and then we'll move into making it an actual networking tool. So first things first, we're going to be able to send our data. So we have to send our data across the wire. So I'm going to go at RPC. We'll make it any peer, comma, quote, call remote, comma, and I'm going to make it unreliable ordered. And then we'll do func send data. And we'll pass in our data as a packed float 32-bit array, comma, and then our ID that we sent it from. And then we'll basically just have a received buffer. So let's go up to the top and create that little receive buffer. So we'll say var, and we'll make a receive buffer. We'll make that a packed float 32 array. And I'm going to actually make this equal a new packed 32-bit array here. So that way we actually initialize this and it exists, because if not, and we just start adding stuff to it, it could cause some problems. So once we have that, we'll just say receive buffer dot append array, and I will pass in that data. And that's going to append the data to our receive buffer. And now once we get our data here, we actually can come up here and type send data dot RPC, and there we go. And then we can pass in our data. So we'll just pass in data, simple enough. Now, normally this is what we'll do, but since we are testing this, let's go ahead and just send data locally, like so. That way we can test this locally. Now, once we actually get our data into our receive buffer, basically what we're doing is we're passing our data into a big buffer and we're holding on to that data until we can read that data and play it back. Now, that means that we have to have some way to actually process that data, right? We need to process that voice information. So we'll come here and we'll say func process voice. And what we'll do is we'll run it just like we run our process. So we'll come down here, process voice. And then basically what we can do is check if our receive buffer dot size is less than or equal to 0. Then let's go ahead and basically return. So if we have nothing in our receive buffer, then there's no point in us processing that data. It does nothing. So we'll just return. Outside of that, once we know that we have data, we can say for I in range min bracket playback dot get frames available, comma receive buffer dot size. So we're basically taking the minimum between our playback frames and our receive buffer frames. And the reason why is just for a bit of error checking. We don't necessarily want to overwrite our frame buffer if our frame buffer hasn't been fully completed. So think of it kind of like this. When if our playback buffer, right, our frames, if our frames have not finished playing, we don't want to overwrite it with additional receive buffer data, if that makes sense. So that's kind of what this is for. Now, once we do that, we can say playback dot push frame. We can pass in a vector2 because it requires a vector2. And the reason why is vector2 is left ear and right ear. So we'll pass in vector2 receive buffer. We'll pass in 0, comma receive buffer bracket 0. And the reason why is because when a person talks into their microphone, they don't have a different voice for left ear versus right ear, right? So since they don't have different voice interactions for left versus right, we're going to apply the same buffer to both sides. If you only applied it to one and not the other, then what would happen is you'd only get sound out of one ear. So now we can basically say receive buffer dot remove at 0. And the reason why we're doing that is because we want to make it so that we only process new information, right? Because we're calling out 0 right here. So we only really want to process that information as it comes in sequentially brand new. And now at this point, we should be okay to test it out. So let's see what happens. What's probably going to go on is we're going to be able to talk and we will hear ourselves talking. So I'm going to hit play. And in theory, you should hear yourself talking. Now, you can hear my voice is a little bit deeper than expected, right? I sound almost like a more adult version of myself, or maybe like one of those. I sound like one of those anonymous people on the TV shows. So what we'll do to fix that is to change our sample frequency. If we look at our remote and you click on our audio stream player, you click on our generator, if this gets set to 48,000, it should fix the issue. So I'm going to stop this real quick. We're going to go ahead and head over to our character, click on this guy, click on our generator, and make this 48,000. Now, I'm sure there's a better way to handle this, and some of you guys will tell me in the comments below that there's probably a better way to handle this, but this is how so we'll hit Control S, we'll click on our test scene, we'll hit play, and you should hear my voice sounding pretty much the exact same as it normally does. And thankfully, at this point, it's basically done. All we need to do is do our networking portion of this. Now, of course, if you guys don't already have your networking, we'll build that out. But if you already do, if you've followed my previous tutorials, then at this point, you're pretty much done. All you have to do is instance your players and you're pretty much good to go. But in this next little section here, I will run over how to build it all and get it so you guys can talk. So let's go ahead and do that. All right, so for the networking portion of this, what we're going to do is we're going to start by building out our server. Now, I'm going to right click detach this script because I don't need it to instance my scene anymore because that's going to get handled by all this networking code. So I'm going to right click, add a child node. I'm going to add in a node and I'm going to call this server like that. Then we're going to right click our node 2D, add a child node. Let's add in another one and we'll call this client. And that's how I'm going to separate my server and my client sections of my code. Now, this is not the best way to handle this, but it is a way to handle this. I'm going to do it this way because it's easier, but in your guys' actual production code, you may want to make these completely separate scenes and have them exist separately than how they currently will exist. Now I'm going to right click my server. I'm going to attach a script and I'm going to create a server.gd. Now, what we need to do is basically allow our user to host their server so that they can do communication. Now, we need some kind of event to happen so that way we know when to set up our servers. And the reason why is because if we have multiple versions of our client open and we run our server on ready, it's going to conflict with each other. So we have to only run one server. So what I'm going to do is I'm going to right click my server, add a child node, and I'm going to add in a button like so. And we'll put that underneath our server. I'm going to go into 2D and I'll make it about this big. I'll put it over here and I'll put host server like that. Now, what host server is going to do is it's going to allow me to host my server. And then I will also control duplicate this, put it underneath my client and say connect to server. And I'm going to drag this over here on the other side. And the reason why I separate these two is because a lot of times when I'm doing my code for communication, I like to put my server on one side, my client stuff on the other side. That way I don't get confused on what they're useful for. Now on my server end, I'm going to change this to server host like that. I'm going to click on my node button down and I'm going to say on button down and connect it to my server. Now, when my host button gets pressed, it needs to basically set up our server. So in order to do that, all we need to do is create a eNet multiplayer peer. So what we'll do is we'll come up here and say var peer is equal to eNet multiplayer peer.new. And then we'll come down here and say when somebody presses this button, that means that they want to host. So we'll say var error is equal to peer.create server, and we get to put in a port. And in my case, I'm going to do 8910 because that's the port I like to do. And then we can check if we have an error, then we'll print that error like that. And I'm actually going to put quote, we have an error for server, colon space quote and plus like that. And now what we'll do is we'll go ahead and instantiate our player scene because our host is going to have a player scene. Obviously, if you're running like a dedicated server, you wouldn't want to host a dedicated player scene, but I'm going to go ahead and do that. So we'll come up here and say var player scene is type packed scene, and I'm going to export that out like that. And what we'll do is when we host our game, we're going to actually instantiate a player scene. And then we need to hook up our multiplayer peer. So multiplayer.multiplayer peer is equal to peer. Now you need to do this so that way the game knows what is its peer. And this is good for unique IDs. This is good for all of those different things, if that makes sense. And now we need to instantiate our actual voice communication system. And if you remember, we had a scene dedicated to that. And I believe we called it character.tscn right here, where it had our character and our audio stream player and stuff like that. So if I come to my test scene here, I'll say up here, I'll say at export var player scene colon packed scene like that. And then I'll come down here and instantiate that scene. So var p is equal to player scene dot instantiate like that. And then I'll add a child p. I'll set its name equal to str1, and then I will say p.getNode. And I'll hit quote, and I believe we called it underneath here audio manager. So we'll say audio manager dot setup audio. and we'll pass in 1. Now, let's take a step back. So what does this do? Well, first we set up our server. Then we check for an error. Then we basically add our server as our multiplayer peer. We say we are the server, we are this multiplayer object. Then after that, we instantiate our player scene. We set the name to 1, and then we set up our audio stuff, much like we did in our original test scene where we just instantiated that object. This is very similar, but here's why I'm using 1. When Godot instantiates a server, its ID is always 1. So that's the reason why we set it that way. Now, again, if you are doing a hosted server that you don't want to be able to communicate with people, then you don't need to instantiate these. But in my case, I do. So I'm basically using this as a way to test and verify my results. So once we have this, we basically are done with our server code. Next, all we have to do is come up here and say peer.poll like that. And that's going to keep that connection open. So that way we don't lose that connection. And then all we need to do is keep track of when people connect to our server. So we'll come up here, we'll say ready, and we'll put multiplayer.peerConnected.connect, and we'll pass in peer connected like that. And then I will duplicate that, and then I'll put peer disconnected and peer disconnected, just like that. There we go. And then we'll add in a function for that. So peer connected. And we'll need to pass in an ID like that. So print peer connected plus ID. And I'll need to str that so we can convert that to a string real quick. And then we need to do the same thing for disconnected. So we'll copy this guy, paste, and put peer disconnected. And there we go. And that's basically pretty much our entire server setup. Now, one of the things that we have to look at is when a peer connects, we need to be able to spawn our actual player scene for that peer. So we'll come in here and basically duplicate this code. So let's copy this, paste it, and then basically pass in our ID instead. So we'll change its name to strid and ID right here. Now, you might be asking why I'm choosing to do my name as an ID. The reason why is because it's going to give us a lot more stable code. Because if you just let Godot name it, it's going to do a random like at blah, blah, blah. And it's going to be at node name at like 6, right? And then it's really hard to know exactly who you're working with. So if you do it as an strid, it makes it a lot easier to identify what node you're working with right here in the left pane right here. So it's just something to keep in mind. Now, once we have this, we can go ahead and actually do our client side. So we'll right click our client, attach a script, attach our client, click on our button, change this to connect to server. We'll go ahead and attach our button to our client and we'll connect that. Now, when we want to do our client stuff, it's basically going to be pretty much the same as our server. So I'm going to come up here. I'm going to copy these guys because we need both of them. So we'll grab both of them, and we will need to also basically duplicate our peer connected code right here and our peer disconnected code. So we'll just basically duplicate those guys like that because they all pretty much are the same. Now we do need to have our player scene. So we'll go back to our server, scroll up, grab both of these guys, copy them, and paste them as well. Now, for this part of the code, you can see we're already instantiating our stuff. We're doing that. But where the major difference is right here when we're connecting to our server. So I'll come in here and I'll just do the client code. So we'll say peer.createClient, and I'm going to hit quote 127.0.0.1. And that's going to be my local host. And then for my port, I'm going to say 8910. And just like how we did with our server, where we actually instantiate our multiplayer stuff and we set our peer, we need to do the exact same thing. So we come in here, enter, paste, and instead of doing our name is equal to 1, what we'll do is we'll say multiplayer dot get unique ID. Then we're going to do the same thing down here. We'll say multiplayer.getUniqueID, and that pretty much should just do it. So all we have to do is hit Control S, go into our test scene here. Let's hit play. We'll hit host server, and we have a crash because I forgot I haven't hooked up my instantiates. So let's do that real quick. So go into our inspector. Player scene is empty. So I believe we called it character. And then we'll do the same thing for our client. We will drag that guy in. And then we're going to hit play, and we'll click host and then connect. Now, hosting seemed to have worked temporarily, but it looks like process the multiplayer isn't currently active. So that's my fault, but I'm also running into a weird error where nothing seems to be going through my microphone anymore. Now, this is fine because we're going to need to clean this up. So what I'll do first is I'll come in here and say if server is ready, and I'll pass this guy back like this, and I'll say var server is ready, and I'll make that a type boolean. And then I'm basically just going to come in here and say whenever the host button is pressed and we run through our entire initialization, we'll just set that to true, and that'll get rid of this little error here. Now we just need to do the same thing on our client side. I have a feeling that we'll need to pull on our client. So well, now I'm getting lots and lots of errors. So let's see what's going on. Multiplayer instance isn't active. So let's hit stop and let's take a look at our client. So somehow our multiplayer stuff isn't working quite how we expected it to. So let me go ahead and try this one more time. So I'm going to come in here. I'm going to go into debug, run multiple instances. I'm going to run 2 instances, and I'm going to hit play. Now, if I hit host, you can hear me talking. If I hit connect, we now have a connection. So good. That at least is working. If we look at our remotes, you can see we have 1, we have a number, we have 1. So that's reasonable. So we have our server player, and we have our server and our listener. And if we go into our second session, it's the exact same thing, but the opposite. Now, that means that we have our sender and our receiver, and then we have our sender and our receiver. So that's kind of correct, but I feel like something is wrong. So what I'm wondering is, A, are we RPCing our stuff? It looks like no, we're just executing it. So let's set it to RPC the data across instead. I don't think that's going to make a difference considering I can't hear myself yet. So I'm assuming that that just didn't work. But if I refresh and hit host and then hit connect, does anything change? And it doesn't sound like it because I'm not hearing myself. So I know that this code is not being executed. You can see right here, it's not being ran. So what if we go in and see if I process mic, that's being ran? Is my RPC coming across? No. If I go into my X max amplitude, that looks like that's running. So it's saying that the volume of what I'm talking about is not loud enough to get sent across. So that leads me to believe that there's something going on with the way that our input is set up. So let's take a look at our character real quick. Autoplay is on, generator, max mix rate is fine. So that all seems correct. Our bus is master, which is totally fine. If we go into our input, our bus is record, which is fine. Correct, that looks fine. Is our connection getting killed? That's possible, but I don't think so. And we're getting a connection. You can see here that we did get our connection. Now, of course, we disconnected, but that's because we had a breakpoint. And a lot of times when a breakpoint happens, it'll disconnect. So that's totally fine. I'm wondering if we need to do a client poll. I don't think so, but we could try it. Let's see if this makes a difference. It's probably not going to, but we can try it. So we'll hit refresh. Well, in this case, we need to go to our test scene, hit refresh, hit host, which will send data RPC. We'll hit host and then we'll hit connect. And we are getting lots and lots of errors. Multiplayer instance is not currently active, which doesn't make any sense considering it definitely is active. Well, I guess it's mad because our client isn't active just yet. So if we go if client connected, and I should probably do a lowercase c like so, we'll pass this over and then we'll make a Boolean. There we go, like that. And then we'll come down here and say on connected to server, client connected is equal to true. That way it just kind of gets rid of that issue right there. So let's see if that makes a difference. So host, connect, we have our connection, but there's still no sound. So if we take a look, dig into this a tiny bit more, this is playing, this is reading, that's fine. This is playing, this is might be reading, this is playing, this is definitely reading. Now, I feel like we don't need to do this because we're getting peer connected number, peer connected number, peer connected number, peer connected number. So there technically should only be 2 messages. So I'm wondering if for some reason our peer connections might be running a little bit of a muck here. So I wonder if I mute this. So Control K to comment, go to our server, do the same thing here. So we'll Control K this as well. And then I'm going to see what happens if I try running this. So host, connect, did that make a difference? No. But that's because our remote says 1 and 1 and the other one. All right, so I think I figured out what the issue is. So it looks like in our audio manager, I commented out if is multiplayer authority. So I was getting a bunch of conflicting information. So that was causing the audio buffer to basically freeze, right? Because it was getting 2 different audio input sources and was causing some issues. So now hopefully this will just work. So we can put that guy on, we can hit play, and then we can come over here and hit host and then hit connect. And you should hear me talking and hearing a slight echo from me, basically the data being transferred. So awesome. It actually works. Now, one of the big things that we have to look at is there a issue with us having an additional node right here? Because you can see the host and the client actually exists and it's duplicating information. So I have a feeling that that's going to be a problem. So the reason why it's being duplicated is because if we look at our server, we have a peer connected right here. Now, it's up to you on if you want to comment this out or not. But basically, that's the reason why it's being duplicated. Is if we hit Control K and we shut this off here, that should solve our problem. So if I hit play, in theory, if I hit host and then I hit connect, everything should work just fine. Now you'll notice that we have a bunch of debugging issues. You can see that it says failed to get path RPC node server 1 audio manager. And the reason why that is because when we commented this out, it's not passing our server information to our client. Now, that's a really long way to say we might not actually need to do it this way, because when you deal with clients and servers, really your node structure should be the same. The reason why we're running into this issue is because our node structure is not perfectly the same. We have our host and our server who's basically acting as almost like an intermediary, right? So we have our stuff underneath our server and we have stuff underneath our client. We don't actually have a consistent location for both of these guys to spawn to. So that's pretty much the reasoning behind it. So what we could do if we wanted to attempt to solve this issue is to have a consistent spot to spawn both of our nodes. So if I come in here, I right click, add in a child node, and I add in a node and I call it game spawn location. If I come into my server here and I just export out a server path, so let's come in here at export var game spawn location. I make it a node path like that. When I do my add child, I basically can just get that node and then add it as a child instead. So I can come in here and say get node game spawn location dot add child. And then I could probably just grab this guy and do the exact same thing, but when a peer is connected. Although technically I don't need to do this because my client should just handle that. So we'll come up here and say game spawn location dot add child, and then do the same thing right here, game spawn location dot add child. And then we can go back to our server, scroll up game spawn location, and add that into right here. And that should actually just solve our problem for us, in theory at least. So if we hit play, we can hit host, and we have a fail because it's a null value. That's my fault. So we'll click on our server, game spawn location. We'll click on this guy, click on our client, game spawn location, click that guy, and then hit play. And in theory, this should just work. So we'll hit host, we'll hit connect, and you should hear multiple versions of me talking again. Now, I just muted my desktop audio so you don't have to hear it, but it is working. And you'll also notice if we go into our remote, you'll see we only have one and the value. And then if we go to our debugger, session 1, you'll see the exact same thing, but the opposite. And that means that everything's connected correctly and everyone's talking to each other. Now, the next step in this is to actually test it out. So how are we going to test this out? Well, that is where DigitalOcean comes in. We need to host this out onto a network somewhere, and then we need to be able to basically ping that guy and be able to talk to it. Now, if you've seen my multiplayer tutorial, you know, at this point, you're pretty much good to go, right? But I always like to give you guys a full complete package. So let's actually finish this up. So let's go up to our server and let's make it so it's dedicated server ready, right? Because if you're going to do this, you got to do it correctly. So what I'm going to do is say if quote dash dash server in os dot get cmd line arguments, then we'll go ahead and basically just say on host button down like that. And I will print a message hosting on plus str 8 9 10 like that. And that should basically just run through this and do all the things as expected. And now we'll basically just host it. So we'll hit project export. We're going to make it into a Linux export. And I don't really need to make any of these changes. Just hit export project. We will go up. We'll create a new folder, call it VOIP tutorial export. Hit OK and hit save. Now, something that we'll have to check is if we go to scene, project settings, we click on run, you'll see our main scene was never defined. So we'll go ahead and do that. So let's grab our test scene, open it up, hit close, scene, project, export, and then we'll export out our project one more time just to make sure we did it correctly. Now, all we have to do is go out to where that file is located. So here, and then VOIP tutorial, not that one, export, and we have these little guys here. What I always like to use is DigitalOcean for my testing because it's really easy to work with. So I'm going to log in and go out to my YouTube droplet. I'm going to click on my console here. I'm going to bring that guy up. And then I already have FileZilla set up for basically transferring my files. And if you have any questions about how to set this up, let me know. But basically it has to do with creating a connection certificate. And I go through all of that in my multiplayer tutorials. So go watch that if you're not sure how to do this. But I'm going to click this guy, connect to my droplet. Now I'm going to navigate over to my VOIP tutorial export. Here they are. I'm going to come over here on the right and I'm going to right click, create a directory and call it VOIP tutorial like that. And I will come into my VOIP tutorial. I'm going to drag these guys into here like so. And now it's going to upload that data for me. And in the meanwhile, I'm going to hit ls cd VOIP tutorial, not CS, D, there we go, LS. And you can see here, I have all of the stuff I need here. Now, I'm going to go ahead and execute this tutorial. Now, the way to do it is first you have to change your permissions of your executable to be executable, right? To be able to be ran. Now, in my case, I'm going to use chmod 777 star. Now, you don't want to do this because this basically means you're running it as root. So if you wanted to, you could do 755 and that should in theory work. So let's try that. So we'll hit ls./VOIP tutorial.x8664, hit enter. And it crashed because it's unable to create the display server, which is fine. So we'll do that --headless --server. Now, what this is doing is it's executing the actual executable. It's running it headless, which means we're not going to get this display server issue. And we're running it as a server. And if you remember in our code, we said that if you run --server, then it's going to run it as a server instance. So if I go back to here and I hit enter, it should host it. So now I should be able to come in here, go into my client, come down here and change this to my server IP address, which I will pull from right here. So I'll copy this guy, minimize this, paste it, Control S, hit play, hit connect to server, and then connect to server. Now, the reason why I'm doing this is because there are two people getting connected. And if I unmute my desktop audio, you should hear me talking a couple of times. So awesome, it works. So at this point, you basically have a very basic VoIP system that should scale relatively well. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested tutorial. So if you have any suggestions, please leave them in the comments below or jump on my GitHub. Link is in the description. And I have an issue board there where I put all of my tutorial suggestions. So please, if you have any suggestions, leave them there. I'll be more than happy to get to them. And hey, if you have any questions or comments, leave them in the comments below or jump on my Discord. Link is in the description and anyone there will do their best to help you out. I'm there pretty much every day and I try to help you guys out as much as I can. But that is all I have for you guys today. So thank you so much again for watching. I will see you all next time. Thanks.